In this question, we have to find the value of other 5 trigonometric function, and we are given that the 6th trigonometric function, which is cos x, is equal to minus 1 upon 2, where x lies in the third quadrant. Let's begin with the solution. First, let us write down the given information that cos x is minus 1 upon 2, where x lies in the third quadrant. And we have to find the value of other 5 trigonometric functions, which are sin x, tan x, cosec x, sec x, and cot x. First, let us begin by finding the value of sin x. Now we know that sin square x plus cos square x is equal to 1. So this implies that sin x is equal to square root of 1 minus cos square x. So this implies that sin x is equal to 1 minus cos x is minus 1 upon 2, and minus 1 upon 2 whole square is 1 upon 4. So this is equal to square root of 4 minus 1 upon 4, and this gives square root of 3 upon 2. Therefore, sin x is equal to square root of 3 upon 2. Now we are given that x lies in the third quadrant and sin function is negative in the third quadrant. Therefore, sin x is equal to minus root 3 upon 2. So here we have sin x is equal to minus of root 3 upon 2. Now let us find the value of tan x. Tan x is given by sin x divided by cos x, and sin x is minus root 3 divided by 2, and cos x is minus half. So this is equal to root 3, and we know that tan function is positive in the third quadrant. Therefore, tan x is equal to root 3. Substituting the value in the table. Now let us find cosec x. Cosec x is given by 1 upon sin x. So this is equal to 1 upon sin x is minus root 3 upon 2. So this is equal to minus of 2 upon root 3. Since cosec function is negative in the third quadrant, therefore its value is minus 2 upon root 3. Now let us find sec x. Sec x is 1 upon cos x. So this is equal to 1 upon minus 1 upon 2. This is equal to minus 2. Therefore, sec x is equal to minus 2. And finally, let us find out cot x. Cot x is the reciprocal of tan x, and tan x is equal to root 3. So cot x is equal to 1 upon root 3. This is positive in the third quadrant. So the value of cot x is 1 upon root 3. So these are the 5 values of the trigonometric functions. This completes the solution. In this question, we have to find the value of other 5 trigonometric functions, and one of the function is given to us, that sin x is equal to 3 upon 5, where x lies in the second quadrant. Let's begin with the solution, and we are given that sin x is equal to 3 upon 5, where x lies in the second quadrant, and we have to find the value of other 5 trigonometric functions, and the other 5 trigonometric functions are cos x, tan x, sec x, cosec x and cot x. So we have to find the values of these 5 trigonometric functions. Now we know that sin square x plus cos square x is equal to 1. So this implies that cos x is equal to square root of 1 minus sin square x. So substituting the value of sin x here, we have square root of 1 minus 3 upon 5 whole square, which is equal to square root of 1 minus 9 upon 25, or this is equal to square root of 16 upon 25, which can be written as 4 upon 5. Therefore, cos x is equal to 4 upon 5. Now we are given that x lies in the second quadrant, and we know that in the second quadrant only sine function and cosec function are positive. Therefore here cos x is negative, and thus we can write the value of cos x as minus 4 by 5 here in this table. Now let us find tan x. Tan x is given by sin x divided by cos x. Sin x is given to us as 3 by 5 and cos x is minus 4 by 5. So this is equal to 3 upon minus 4 or minus 3 upon 4. Therefore, tan x is minus 3 upon 4. Now next, let us find sec x. Sec x is given by 1 upon cos x. So we have 1 divided by minus 4 upon 5. So this is 5 upon minus 4, or this can be written as minus 5 upon 4. Therefore, sec x is minus 5 upon 4. Now let us find out cosec x. Cosec x is given by 1 upon sin x. So we have 1 upon 3 upon 5, and this is equal to 5 upon 3. Therefore, cosec x is 5 upon 3. Finally, we have to find the value of cot x. And cot x is equal to 1 upon tan x. So we have 1 upon tan x is equal to minus 3 by 4. So here we have minus 3 by 4. So this can be written as 4 upon minus 3 or minus 4 upon 3. Therefore, here the value of cot x is minus 4 upon 3. So hence we have found the values of the other 5 trigonometric functions. With this, we come to the end of the solution. In this question, we have to find the value of other 5 trigonometric function, and one trigonometric function is given to us, that cot x is equal to 3 upon 4, where x lies in the third quadrant. Let's begin with the solution. And here, out of 6 trigonometric functions, we are given one trigonometric function cot x, whose value is 3 upon 4, and we are also given that x lies in the third quadrant. And we have to find the value of the other 5 trigonometric functions, that is sin x, cos x, tan x, cosec x and sec x, for x lying in the third quadrant. Now we know that cosec square x is equal to 1 plus cot square x. So this implies that cosec x is equal to square root of 1 plus cot square x. So this is equal to square root of 1 plus the value of cot x is 3 by 4. So we have 3 upon 4 whole square. So this is equal to square root of 16 plus 9 divided by 16, which is equal to square root of 25 divided by 16, and this is equal to 5 by 4. Therefore, cosec x is equal to 5 by 4. Now, we are given that x lies in the third quadrant, and in the third quadrant only tan x and cot x are positive, and cosec x in the third quadrant will be negative. Therefore, the value of cosec x is minus 5 by 4. Let us write down the value here. So, value of cosec x is minus 5 by 4. Now, let us find sin x. Sin x we know is the reciprocal of cosec x, that is 1 upon cosec x. So, this is equal to 1 upon minus 5 by 4, which is equal to minus 4 by 5. Therefore, sin x is equal to minus 4 by 5. Now, let us find the value of tan x. Tan x is the reciprocal of cot x. So, this is equal to 1 upon 3 upon 4. So, this is equal to 4 upon 3. So, the value of tan x is 4 upon 3. Now, let us find the value of cos x. Now, cos x we know that is equal to 1 minus sin square x. So, this is equal to square root of 1 minus the value of sin x is minus 4 upon 5. So, we have minus 4 upon 5 whole square, since sin square x is sin x whole square. So, this is equal to square root of 1 minus 16 upon 25, which is equal to square root of 25 minus 16 divided by 25, which is equal to square root of 9 divided by 25, which is equal to 3 divided by 5. Therefore, cos x is equal to 3 divided by 5. Now, since we are given that x lies in the third quadrant, and in the third quadrant only tan and cot are positive, therefore, cos x is negative. Hence, the value of cos x will be cos x is equal to minus 3 by 5. So, let us substitute the value of cos x in the table, which is minus 3 by 5. Finally, we have to find sec x, and sec x is the reciprocal of cos x, that is 1 divided by minus 3 upon 5. So, this is equal to minus 5 upon 3. Therefore, the value of sec x is minus 5 upon 3. So, here we have minus 5 upon 3. So, thus we have found the value of other 5 trigonometric functions. This completes the solution. In this question, we are given the value of one trigonometric function sec x, which is equal to 13 upon 5, where x lies in the fourth quadrant. We have to find the value of the other 5 trigonometric functions. Let's begin with the solution. And we are given that sec x is equal to 13 upon 5, where x lies in the fourth quadrant, and we have to find the value of sin x, cos x, tan x, cosec x and cot x. Now we know that 1 plus tan square x is equal to sec square x. So this implies that tan x is equal to square root of sec square x minus 1. So this is equal to square root of 13 upon 5 whole square minus 1, which is equal to square root of 169 minus 25 divided by 25, or which is equal to 144 divided by 25. So this is equal to 12 divided by 5. Therefore, tan x is equal to 12 divided by 5. And we know that in the fourth quadrant only cos x and sec x are positive. Therefore, tan x will be negative in the fourth quadrant. Hence, the value of tan x is minus 12 upon 5. Let us write it down in the table. Now, cot x is equal to 1 upon tan x. So this is equal to 1 upon minus 12 upon 5, which is equal to minus 5 upon 12. Let us write down this value also. So this is minus 5 upon 12. Now, cos x is the reciprocal of sec x, which is given to us. So this is equal to 1 upon 13 by 5, which is equal to 5 upon 13. So the value of cos x is 5 upon 13. Now let us find sin x. We know that sin x is equal to square root of 1 minus cos square x, that is square root of 1 minus 5 upon 13 whole square, which is equal to square root of 169 minus 25 divided by 169, which is equal to square root of 144 by 169. So this is equal to 12 upon 13. And we know that since sin x is not positive in the fourth quadrant, therefore sin x is equal to minus 12 upon 13, since in the fourth quadrant only cos x and sec x are positive. So the value of sin x is minus 12 upon 13. Now let us find the last trigonometric function, which is cosec x. Cosec x is the reciprocal of sin x, that is 1 upon minus 12 upon 13. So this is equal to minus 13 upon 12. So here we have minus 13 upon 12. So thus we have found all the 5 trigonometric functions. This completes the solution. In this question, we have to find the value of the 5 trigonometric functions, and we are given the value of one trigonometric function, that is tan x, which is equal to minus 5 upon 12, and we are also given that x lies in the second quadrant. Let's begin with the solution. So we are given that tan x is equal to minus 5 upon 12, where x lies in the second quadrant, and we have to find the value of sin x, cos x, cosec x, sec x and cot x. We know that 1 plus tan square x is equal to sec square x. So this implies that sec x is equal to square root of 1 plus tan square x. So we have a square root of, substituting the value of tan x, since tan square x can be written as tan x whole square. So we have minus 5 upon 12 whole square, which is equal to square root of 144 plus 25 divided by 144. So this is equal to square root of 169 divided by 144, which is equal to 13 divided by 12. Therefore, sec x is equal to 13 divided by 12. Now we are given that x lies in the second quadrant, and in the second quadrant we know that only sine function and cosec functions are positive. Therefore, sec x will be negative in the second quadrant. So the value of sec x is minus 13 upon 12. Now let us find cos x. Cos x is the reciprocal of sec x. So cos x is minus 12 upon 13. Now we are given tan x. So we can find cot x. Since cot x is the reciprocal of tan x, so we have 1 upon minus 5 upon 12, which is equal to minus 12 upon 5. So the value of cot x is minus 12 upon 5. Now we have to find sin x. Sin x is equal to square root of 1 minus cos square x. So this is equal to square root of 1 minus cos x is minus 12 upon 13 whole square. So this is equal to square root of 169 minus 144 divided by 169. So this is equal to square root of 25 upon 169, which is equal to 5 upon 13. Therefore, sin x is equal to 5 upon 13. Now since x lies in the second quadrant and in the second quadrant sin x is positive, therefore sin x is 5 upon 13. And the value of cosec x is given by 1 upon sin x, that is 1 upon 5 upon 13, which is equal to 13 divided by 5. So the value of cosec x is 13 divided by 5. So thus we have found the values of the other 5 trigonometric functions. This completes the solution. In this question we have to find the value of the trigonometric function sin 765 degrees. Let's begin with the solution. And sin 765 degrees can be written as sin 2 into 360 degrees plus 45 degrees, and this is equal to sin 45 degrees, since we know that sin 2n pi plus theta is equal to sin theta, and this further implies that sin 45 degrees is 1 upon root 2. Therefore, sin 765 degrees is equal to 1 upon root 2. This completes the solution. In this question, we have to find the value of the trigonometric function cosec minus 1410 degrees. Let's begin with the solution. And we have cosec minus 1410 degrees. So this can be written as cosec 1410 degrees with a negative sign, since we know that cosec of minus theta is minus cosec theta. Now this is further equal to minus cosec into 4 into 360 degrees minus 30 degrees, and this is equal to minus of minus cosec 30 degrees. Since we know that cosec 2n pi minus theta is equal to minus cosec theta. So this is equal to cosec 30 degrees, which is equal to 2. Therefore, the value of cosec minus 1410 degrees is equal to 2. This completes the solution. In this question, we have to find the value of the trigonometric function tan 19 pi upon 3. So let's begin with the solution. And tan 19 pi upon 3 can be written as tan 6 pi plus pi upon 3, and this is equal to tan pi by 3, since we know that tan 2n pi plus theta is equal to tan theta. Now we know that tan pi by 3, that is tan 60 degrees, square root of 3. Therefore, tan 19 pi by 3 is equal to square root of 3. This completes the solution. In this question, we have to find the value of the trigonometric function sin minus 11 pi upon 3. Let's begin with the solution. And we have sin minus 11 pi upon 3. So this can be written as minus sin 11 pi by 3, since we know that sin of minus theta is equal to minus sin theta. Now this can be written as minus sin 2 pi plus 5 pi upon 3, and this is equal to minus sin 5 pi upon 3, and this is because we know that sin 2 pi plus theta is equal to sin theta. Now this is further equal to minus sin. Now 5 pi by 3 can be written as 2 pi minus pi by 3. Now 2 pi minus pi by 3 is in the fourth quadrant, and in the fourth quadrant sine function is negative, so we have minus of minus sine pi by 3. So this is equal to minus minus is plus. We have sine pi by 3, and the value of sine 60 degrees is square root 3 upon 2. Therefore, the value of sine minus 11 pi upon 3 is equal to root 3 upon 2. This completes the solution. In this question, we have to find the value of the trigonometric function cot minus 15 pi upon 4. So let's begin with the solution, and we have to find the value of cot minus 15 pi divided by 4. So this is equal to minus cot 15 pi by 4, since we know that cot of minus theta is equal to minus cot theta. Now this is equal to minus cot 15 pi by 4 can be written as 2 pi plus 7 pi by 4. Now this is equal to minus cot 7 pi by 4, as we know that cot of 2 pi plus theta is equal to cot theta. Now this is further equal to minus cot 7 pi by 4 can be written as 2 pi minus pi by 4, and this is equal to minus of, now 2 pi minus pi by 4 is in the fourth quadrant, and in the fourth quadrant cot function is negative, so we have minus cot pi by 4, and minus minus is plus, so we have cot pi by 4, and cot pi by 4, that is cot 45 degrees, is 1. Therefore, the value of cot minus 15 Pi by 4 is equal to 1. This completes the solution.